Appetite and food intake are controlled by the interplay between physiological mechanisms and external factors. Appetite-suppressing signals, also known as satiety signals, are facilitated by hormones leptin, which is secreted by adipose tissue, and insulin secreted by the pancreas, as well as peptides produced in the brain. Appetite-enhancing signals come from the brain's peptides, known as neuropeptide Y, an AGO-UT-related peptide. These help to maintain a balance between energy demand and availability. The neurotransmitters GABA, serotonin, and oxytocin appear to influence behaviors which are related to eating. In addition, the gut produces signaling molecules, and these alter appetite, such as cholecystokinin, which helps to curb eating once the stomach is full, and ghrelin, which counterbalances the effects of leptin by stimulating appetite and eating. This complex network of signals governs your desire to eat and your motivation to modify your behavior accordingly. The sensitivity of the neural pathways involved in appetite is greatly affected by genetic and epigenetic factors. In obesity, signaling along these appetite-regulating pathways are generally diminished, and this can make control over eating behaviors extremely difficult. Ghrelin is a hormone produced mainly in the empty stomach, with functions that overlap those of the adipokines. Ghrelin stimulates eating through complex effects in the brain, where it increases the drive to eat. It enhances a sense of well-being from eating, and it modulates taste and smell and upregulates food-seeking behavior. It also contributes to regulating the gut motility and the digestive function, and it has a range of metabolic effects, such as suppressing thermogenesis in brown adipose tissue, stimulating fat production and storage, and reducing insulin release and raising blood sugar levels. Obesity has been linked to dysfunctional overproduction of ghrelin. Calorie reduction and weight loss further raise the ghrelin levels, adding to the difficulty of achieving a healthy weight loss. Insulin resistance and obesity are related conditions, and they often occur together. Insulin is a key metabolic hormone, and it's produced in the pancreas in response to high nutrient availability. In healthy conditions, insulin increases the glucose uptake by the cells, which stores excess glucose as glycogen or fat, and prevents glucose generation while stimulating lipid production by the liver. In unhealthy conditions, including those caused by a high-calorie, nutrient-poor diet, low-level inflammation causes fat cells to become increasingly resistant to the effects of insulin. As insulin resistance progresses, levels of both insulin and glucose rise, and adipose tissue releases free fatty acids into circulation. These excess fatty acids then accumulate in the organs that are not equipped to process or store the extra fat. This adipose deposition of the fat is known as lipotoxicity, a condition that causes tissues and organ dysfunction and accelerates widespread inflammatory signals, insulin resistance, and poor vascular function. Because insulin-resistant tissue generates high levels of tissue-damaging free radicals and instigates chronic low-level inflammation, insulin resistance has been suggested to be an important link between chronic metabolic and inflammatory disorders. Long-term overeating with a high-fat Western-type diet has been shown in many studies to raise the risk of insulin resistance and obesity, particularly in the abdomen, as well as high cholesterol and triglyceride levels and high blood pressure. This cluster of related conditions, which often occur together and contribute to a higher risk of type 2 diabetes and cardiovascular disease, are called metabolic syndrome. People with metabolic syndrome also have increased risk of neurological diseases, liver cirrhosis, autoimmune disease, and some cancers, as well as death from all cause. For more on weight loss, continue on the series, or for information on herbs, supplements, and natural treatment plans, check out my website.